The dot product is actually closely related with the angle between two vectors and the magnitudes of those vectors. I'm going to draw a little picture here. I'm not going to go through the full proof of the formula that's coming, but I want to show you where it comes from. If you have two vectors v and w, we'll go ahead and just draw them. So here will be the vector v and the vector w. These vectors, well, if we think of this initial point as the origin, we place them at the origin. Oops, that not what I wanted. So place at the origin. Okay. Then of course these vectors we can write as points. We'll call that, say, A and B. This point C and D. And this length right here, this vector is then of course the third side of this triangle that has this angle here. We're going to call this angle theta. And if we then apply the law of cosines to this triangle, then we actually, just with a bit of algebra and canceling some things, we end up with a really cool formula. And the formula is this, that v dot w is equal to the magnitude of v times the magnitude of w times the cosine of the angle between those two vectors. So this is an alternative form for the dot product. For any two non-zero vectors, the angle between them, and this angle is the smallest non-negative angle between them, then this formula here holds. Very powerful formula that relates our dot product to the magnitude and the angle between them. And of course, from that, there's a whole lot of things that follows. Like you can get the angle between the vectors by simply solving here for that angle theta. So divide by those magnitudes and take the inverse cosine. So doing that, we get our v dot w over the magnitude of v, magnitude of w. Okay, that's the cosine of theta. And so if I do the cosine inverse of that, then I get that angle theta. So very powerful formula with a lot of different applications.